tell people you were.
Example number 1, we have the function f of x is equal to x cubed minus x. And so what we would like to do is we would like to know the average rate of change over the interval x equals 1 to x equals 3. And so remember that this is interval notation, not a Cartesian coordinate. In other words, what we're trying to do is figure out what happens when x equals 1 and what happens when x equals 3. If we want to figure out the average rate of change, what we could do is we could say f of x and evaluate it at 1 and at 3. In other words, I could say f of 1 is equal to 1 cubed minus 1, right? Which is equal to 0. So when x equals 1, my f of x or y value is equal to 0. If I evaluate my function at 3, then I say 3 cubed minus 3 is equal to 27 minus 3 is 24. So now the rate of change is really the slope, which is really delta y over delta x. So delta x would be the change in x. Well, how much did I change in x?
2.
2. I added 2 to get to go from 1 to 3. Now what would be delta y?
24.
I added 24. So I have a positive 24 over 2, which is equal to 12.
Yes.
Okay? So now what we want to do is we want to do this a little bit symbolically and then start to apply it. Well, let's back up a little bit to our algebra days. We used to say that the slope was delta y, y sub 2 minus y sub 1, and delta x, which is x sub 2 minus x sub 1. But if I change that, because I'm smarter now, I'm in an AP Calc class, I might want to use interval notation and function notation instead of the subset notation. In other words, f of 2, or I'm sorry, y sub 2 is the same as f of b. And I'm just going to leave that up there and let it soak in for a second. All right? And then y sub 2 is f of a. And then x sub 2 is b minus a.
How long did you actually go to college for?
So then I'm going to say 24 minus 0 is equal to 3 minus 1, which is equal to 24 over 2, which gives us 12. We did all that work so that we could kind of understand what the average rate of change is. The average rate of change is the function evaluated at an upper boundary minus the lower boundary all over the boundaries. Or the difference of the boundaries, I should say. So what we're really saying is when we want to find the rate of change of something, and I should probably put the word average in front of it, we could use the formula f of b minus f of a all over b minus a. This is important. You guys need to know this. We're going to start to, at some point in time, talk about a fundamental theorem of calculus. And what that means is they give it the title Fundamental Theorem of Calculus because it's important and it's all based on interval notation. This a comma b business. So we need to start looking and thinking in terms of this. Okay? Are there any questions?